Hello, my name is Doug Ferrier. Welcome to my presentation on big data and electric cars. A quick background on myself. I am in the PhD program, which is part of the ISU consortium. This is my last semester of PhD coursework. I started from scratch, no master's course transferred, so it has been a long journey. I am the first international student to complete the coursework for a PhD in technology management through the ISU consortium. You can see the rest of my education there. We're going to be talking about big data and electric cars, and there are some terms used throughout this presentation. ICE, you will hear ICE. You'll hear that a lot more in the future, referring to internal combustion engine cars. We have EVs as electric vehicles. We have big data. Okay. Data that contains greater variety arriving in increasing volumes and with ever higher velocity. We'll talk more about that in a minute. We have PHEV. These are your plug-in hybrid electric vehicles. We have your OBD2, your onboard diagnostics, your ECUs, which are electronic control units, and your SOH, your state of health of the battery. So, big data. What is big data? So, the Gartner Group, 2001, which is still the most commonly used definition of big data. So, big data is data that contains greater variety arriving in increasing volumes and with ever higher velocity. So what that can mean is if we look at volume, it's really the 3 V's they call it. So we can look at volume. So the volume can be in the tens of terabytes or more. Velocity of data is very important, and for EVs it is in real time. So variety refers to the many types of data that are available. The data generated from an EV can span over 159 columns covering information such as elevation, ambient temperature, tire pressure, SOH, and charge mode, just to name a few. So 2 examples of collecting big data. One was electric vehicles are changing the way people drive, and researchers at Ford used EVs and PHEVs to collect over 3 billion data records from over 300 million miles of travel, which allowed insights into car and driver behavior not previously researched with ICE vehicles. Another example is for one EV during a 2-hour, 9-minute journey, there were 2,284 lines of data created across 159 columns using a Nissan Leaf Spy Pro smartphone web application and a Bluetooth dongle. A CSV file is generated for every trip where the smartphone application is connected, containing these 159 columns. The trips can generate hundreds or thousands of lines organized inside a CSV file depending on many variables. Files are then automatically transferred to the cloud after a trip. So it is very easy to access, store, and analyze large amounts of data generated by the EV. There is a simple Bluetooth dongle, which you can see here in figure 1, that connects to the ODB2 port inside the EV to relay information to a smartphone application. The combination of the smartphone application and Bluetooth dongle allows almost any EV owner to actively see what is happening with their vehicle. EVs such as Ford Focus Electric, Kia Soul EVs, Nissan Leaf, and BMW i3 have a smartphone application specifically for use with them. Leaf Spy and Kia Soul Spy are 2 of the smartphone applications. These Bluetooth dongles and smartphone applications cost around $20 each. The smartphone application creates an entry within the CSV file every 3 to 10 seconds, depending on what is happening with changes in the environment and the car. So one CSV file looked at, I examined, contained 2,284 lines in a 2-hour, 9-minute trip. In a separate 2-hour, 42-minute trip, there were 1,829 lines of created data across 159 columns using the Nissan Leaf Spy Pro application. Some of the columns are filled with multiple readings of one variable, such as tire pressure, which obviously has 4 values, one for each tire. Every time the application is started and connected to the Bluetooth dongle, a new record/CSV file is created. CSV files are stored in the cloud via Dropbox for those generated by Leaf Spy Pro. And you can combine them and analyze them from there. If you were to combine a whole week's data or a whole month, you start getting into that big data that can actually be analyzed, getting into the tens of thousands, if not hundreds of thousands of records if we look over a year or two span. So this figure here is an example of the first 16 columns of data that you would typically see in a CSV file. Hundreds or thousands of these files per car are created based on how often the smartphone application is connected and used. Okay, these files and setup using the smartphone application and Bluetooth dongle can be used with the original Leafs starting back in 2010 right up until today's Leafs in 2020. So Ahmed and Kapadia in 2017 gathered some data with Ford, okay, and they only focused on Ford PHEVs and the Ford Focus Electric. So the Ford PHEVs and EVs, the Ford Focus Electric, all have a 2G modem built into them. So the generated data is sent to the cloud server from the modem, and then the smartphone application called My Ford Mobile was used to actually retrieve the data. Okay. The goal for their paper was to look at customer behaviors via analyzing the big data consisting of 3 billion data records. The driving behavior was analyzed in terms of trips and distance. They note that the EVs were driven shorter distances daily as compared to the PHEVs because of the 76-mile range for a Ford Focus EV. The results found that this has great implications on the value of PHEVs for customers, as they observed that there is no need for customers to change their driving habits. However, that being said, there is no mention of the cost to run the PHEVs using their ICE. Plus, there's no DC fast charging. There's none that seems to be present or used during the study so that the Ford Focus EV could travel more than 76 miles a day. Another study looked at battery degradation. Battery degradation is a key aspect in the optimizing of range for an EV throughout its lifetime. Chen, He, Li, and Chen investigated 2 aspects of battery deterioration: calendar and cycle aging. Although cycle aging is important, calendar is relevant to the generated data presented due to the state of charge. Calendar aging is when a battery is examined over time when the EV is not active or it is in storage. So the SOC, the state of charge, is present in the CSV file generated by the OBD2 Bluetooth connection to the smartphone application, and its values in the G column for the Leaf Spy application. Chen et al. Used calendar experiments that found temperature had a great influence on the battery capacity, along with the storage SOC having a lesser but still important impact on it. Since the storage SOC impacts the battery capacity, it's important to examine the SOC values before the EV goes into prolonged storage, especially when it's in a hot area. So the study found the optimal capacity for an EV battery stored for a prolonged period at temperatures of 25, 45, and 60 was 20%, not 100%. So big data in electric cars, one of the most important parts of information, or the most important field, is the SOH generated through the smartphone application, because it does show battery degradation over time. There are several factors affecting SOH, which can be found using the feedback from the generated data. So Szymanski and Gautama could have used this big data generation in their study on forecasting the state of health of electric vehicle batteries to evaluate the viability of car sharing practices. Driving data was used to determine the SOH of the battery, not an OBD2 with an application. Okay, it can be determined from the generated data when to replace the battery in the EV. The SOH is shown on the Leaf and Kia Soul EV Spy applications, and you can see it listed here in the chart, and at the top in red you can see SOH. This is of a Nissan Leaf, and its SOH is 81.88%. Okay, you can also see the odometer there of 110,000 kilometers, 10,729 kilometers. So figure 3 on the left-hand side shows a selection of 20 SOH lines inside one CSV file generated from one trip. Okay, so this is just a selection. An EV owner or operator can see the transition from 81.92 to 81.88 SOH. The higher values represent a healthier battery. So the state of health is an indication of the battery's ability to hold and release energy, and is reported as a percentage. With the battery, when the battery is new, the SOH is 100%. When the SOH drops to 85% for a month or so, the Leaf loses the first capacity level segment displayed on the right side of the Leaf's central dash display. The capacity gauge is the rightmost outer curved column of segments next to 1 at the top and 0 at the bottom, with the last two segments being colored red. The use of the data in figure 4 below is excellent to determine how much charging affects the health of the battery. A type 2 shown here in the last column is level 2 charging from 200 to 240 volts. Most home EV chargers are level 2. I'm going to talk a little bit more about charging in a minute. So another key issue is efficiency. Efficiency is about helping the operator of the EV detect patterns that end in less range. We want to remove those types of patterns. Over and all, an operator should see the efficiency increase over time if they are driving based on the feedback from the application data. There are two efficiency graphs provided through the Leaf Spy application that can provide data to become more aware of driving the car more efficiently to optimize the range. The efficiency graph here shows the last 32 samples of efficiency at 1 kilometer intervals while driving, and the last value in blue, okay, is the most recent. The example is from in-town driving. Okay, so many of the values are very high here. The blue shows a value of 5.9 kilometers per kilowatt hour, which is very low for city driving. Okay, typically you're going to see those other higher values as you drive in the city. Okay, the Kia Soul EV Spy does not offer those efficiency values. Okay, one thing you'll notice with, as mentioned before, that the city driving actually is much more efficient than highway driving, and I'll talk a little bit more about that in a second. So tire pressures are another issue, okay, that it generates a lot of information The tire pressure is constantly monitored using the Leaf or Kia Soul Spy applications. It is important for optimized range to keep the tires properly inflated. The tire pressure does change as tires warm up. Above, okay, are 10 selected rows directly above of tire pressure data out of 2,284 rows in the CSV file that we talked about earlier. The data is from March of this year, March 20th, during a trip of approximately 2 hours. As determined from the data, the front right and rear right tires need to be inflated. The value should be around 44 psi for 16-inch tires on a Nissan Leaf. Results have shown mean some tires need inflating. Both the Leaf and Kia Soul EV report on tire data. Okay, you can see also up in the left-hand corner that we have the 4 values. The DW, DX, DY, DZ are all, those are the column headings for each of the tires. So one of the issues, as I was talking about efficiency, braking. So the brake systems in EVs are regenerative. The braking and power generation can be optimized from the feedback provided by the smartphone application. The report from Peterson, Apt, and Whitaker, as cited in Szymanski and Gautama, says around 7% of energy during a typical drive is regained via the regenerative braking. The information generated through braking is useful for planning trips because on highways there is little braking and a change of route may optimize the battery for greater range. This is the city versus highway driving I was discussing. Myself, in 2019, I did a study and it found a similar result during this study of infrastructure in Western New York when I changed the route from I-190 thruway to Highway 20 to save on energy. You can see here in the graph on the right-hand side that the green represents the regeneration and red is the friction. Again, this was in the city. You can see there's a lot of stopping. There's a very high amount of regeneration, which is excellent. Red is the friction. Less would be better, but again, when we're in the city, stop lights, stop signs, especially where I live, we're going to get a lot of that. So the final key issue is talking about charging. Okay, so charging is one of the most important aspects of preventing battery degradation. Within the data generated from ODB2 connections to smartphone applications is the ability to determine the type of charger used. Okay, so the charge mode in the EM column, again, that's in our 159 columns under the EM, it provides a value between 0 and 4. Okay, the charging values are represented as 0 for not charging, level 1. This is your plug-in, would be plug-in to the side of your house, for example. Okay, a standard plug is used. Okay. Then we have our level 2 charging, as I mentioned before, which is a 200 to 240 volt connection. And then we have our level 3 quick charging. These are typically found at businesses. These are very fast. Okay, very often we call these DC fast charging. Okay, or through this app, it's actually called quick charging. Okay. So in the table, as shown below here, the far right value is the charge mode. So you can see here we have two zeros and then two twos. Okay, the SOH in the far left value, which here we're showing 81.92. Okay, and you can see it is actually lowering by 0.04 at the time of charging. So you can see going for 0 charge to a level 2 charger, and you can see the SOH moving from 81.92 to 81.88. Now, the drop here is coincidental, okay, regarding the precise timing, okay, but the large amounts of generated data provide insights that SOH is affected more severely after using a level 3 charger versus a level 2. Very often, you're going to see After the charge, it drops slightly, like I said in this one, 0.04. However, if we look at the drop in SOH shortly after using a level 3 charger, it sometimes or often it will show a change. Okay, and the change example I have found in some of my files here are moving from an 85.54 health down to an 85.2. Okay, so that is a 0.34 drop. That is a lot. Okay, and if you discuss things and look at the research, very often this is very common amongst EVs, and why a lot of people do shy away from a lot of quick charging or level 3 DC fast charging. Okay, you can see here in the final slide. Okay, this is taken from the top portion of one of those, the main slides that I showed earlier, showing the actual chart. This actually shows the cumulative quick charge and level 1/level 2 chargers. Okay, so here, this car has done over 110,729 kilometers, which is a very high amount for an electric car. Okay, and especially this is a newer car. Okay, and you can also see here, so we have 367 quick charges. That's a very high number. And then we have over 1,831 level 1 and level 2 charges. We would expect very high numbers because of the odometer at over 110,000. That's over 65,000 miles. Okay, and on a newer car, that is quite a few miles. Okay, a car less than 3 years old. All right, so that is the end of my presentation. However, I do have references here. At the end here, you can see all the different references I have used. And that is the end of my presentation. I hope you enjoyed it. Thank you.